Hello.
All right. Hey, Erica. Hey, Mona.
Hi.
Hi, everybody.
Hello.
Let's
Hi,
wait a
Erica.
couple more minutes.
Nice to see you again, Mona.
Nice to see you too.
Yeah.
Feel free to add your names to the agenda as well. And yeah, if you'd like to add affiliations as well. All right. We're just waiting for folks to join. So let's wait a couple more minutes. All right. Okay, and let's start. I don't see many people today, but hopefully I blasted out a message on Slack. Hopefully folks will join. Feel free to add your names. Mona, you're first. We're starting with introductions.
Yes, right. So I think I introduced myself before, but hi, everybody. I'm Mona Borham. I work as an independent cloud native and platform architect. Previously, I worked for VMware. I'm interested in every single platform, and of course, because I'm here, I'm interested in intelligent solution on top of cloud native. Happy to be here.
Then next, Erica.
Hi, my name is Erica Huberg, and I am a maintainer on Envoy AI Gateway. And Huamin from Red Hat suggested it'd be great to just do a little introduction of that project here and share what it is, how people can get involved. And I'm also really excited to be here to hear what you all people talk about normally. So Huamin, yeah, requested me to show up here. So here I am. Hopefully I'll have a great time. So nice to meet you all.
Awesome. Thank you for joining. Looking forward. Okay, I guess I'm next. Hey everyone, I am Andres Zaruk. I'm one of the coolies for this working group. I work at Red Hat as a product manager, and looking forward to listening to today's talk and collaborating with all of you. Anka, you're next.
Hi, everybody. Good morning, good evening. Happy Friday. And for those who celebrate, happy St. Valentine. So I'm at IBM. I lead the compliance digitization transformation, and of course, AI hit us as well. And I am here for an effort, a project that we started with Ricardo and a few of us, Vikas and Talia and so on the safeguards for AI leveraging the latest compliance as code digital artifacts. So it has two sides to the coin. One is really creating the safeguards at the technology level. We have them at higher level. And second, expressing them in a programmatic way.
Awesome. Thank you for joining. Vikas.
Hi, I'm Vikas Agarwal. I'm from IBM Research in India. As Anka mentioned, I'm working with Anka and other folks on the compliance score side, where we have an Oscar Compass CNCF sandbox project. And as part of this working group, we are looking at how we can enable compliance for AI platforms, tools, workloads, and create Oscar artifacts corresponding to that. Yeah.
Great to have you
Thank you.
here, Vikas. Gorkem.
Hey, I'm Görkem Marjan. I'm the CTO of Jozu. Well, before Jozu, I was a distinguished engineer with Red Hat, and I'm here to today talk about the GitOps project, which is a CNCF sandbox candidate.
Awesome. Looking forward to the talk. The one and only Ricardo.
Hi, I'm Ricardo. I'm one of the leads for this working group, and I work at Snowflake, running or helping run infrastructure to run AI, ML workloads. And yeah, we're using open source. We use the Volcano open source project. So interested in that, and yeah, interested in being in this group.
Awesome. Claudia.
Hey everyone, good to see everyone here again. I'm Claudia, I'm from IBM Research in New York. I work on Kubernetes and OpenShift topics, especially monitoring of AI workloads and also building infrastructure for training, inference workloads on Kubernetes.
Awesome. Thank you all for joining today. So I will go through the list of agenda items, especially the presentation. So there was, and I wasn't here last time. So Ricardo, if you're here, like I think there was a talk from Samuel Wan about leveraging Gen AI to benefit open source.
We couldn't get to that talk because he's located in China, so he wasn't able to join the meeting. But if we can actually play the talk but I'm not really sure if you want to go through other agenda items before that.
Yeah, I can put the link to the talk in here for folks to watch. If he joins, we can then he can go over it again like face to face. Does that make sense?
Sounds good.
Okay.
Do you mind sharing your screen?
Oh, right. Okay. You should have told me earlier. Let me see. All right. Okay, do you see my screen now?
Yeah.
Okay. All right. Then I guess next in line is Kaitops. Gorkem, you're next.
Alrighty. Guess I can share the slides. That makes it easier to talk over them, right?
Yeah, and I'll stop sharing. I haven't shared like for a long time. Let's see if I. All right, please go ahead.
Let's see. Alrighty. So I'm going to talk about the GitOps open source project, which is a CNCF sandbox candidate. We're going to talk about a little bit of what GitOps is, what the community looks like, what the roadmap looks like, and then I'll talk a little bit about the standardization issue, the efforts that is ongoing. So the GitOps itself as a project is its aim is to enhance collaboration between data scientists, application developers, and SREs. But the way to do that for GitOps is to create vendor neutral standards and do the collaboration based on the vendor neutral standards, especially for packaging and versioning of AI ML projects. What do we mean by that? Well, GitOps actually consists of three main pieces. The first piece is what we call a model kit, model kit is essentially an OCI artifact. And then we have a kit file, which kind of defines the structure of the model kit. And we have a CLI and a Python library. I'll go a little bit more detail on that. So model kit is essentially the crown jewel on GitOps because it's the OCI compliant packaging format. It's an OCI artifact. It enables packaging different AI ML artifacts into an OCI artifact. One of the things that it is able to do is because it's not using the same method as the images, like it's not an additive package, but rather you can get single layers and work with single layers. It allows you to work only with data sets and only with certain data sets with models and so on and so forth. So that actually helps with the different stages of the model lifecycle where you are, for instance, when you're doing training, you just want one data set, and then when you're doing an evaluation, you want the other data set, and so on and so forth. I kind of joke about this a little bit, say that, hey, we are replacing Excel because we have been encountering many organizations who are actually putting their data sets and their trained models in an Excel sheet to be able to track the data sets that trained those models. So with this, you actually don't need them. You can just package them together and it keeps them in an immutable package. As I said a little bit, it's a little bit different than what Docker images are. It allows you to have artifacts in individual layers, and you are able to retrieve those layers by itself. So it's not additive in that sense. And this is, what a model kit manifest looks like. If you are familiar with the OCI artifact specification, this is what you would expect from an OCI artifact. So it's completely compliant, works with any OCI registry that we could test with so far. So kit file, this is essentially how we tell our tools what to package. It is a YAML file, and it essentially, I have an example here that's going to go easier. It basically tells us what is the package about and what to put into the different layers when we are packaging a project. One of the things that we didn't anticipate, which came up as people started to adopt GitOps, was they also want to be able to put some of the parameters that are either application specific or model specific into these files and be able to retrieve them later. So what we do is we package the kit file, and as you can see, there is a code layer and a data set layer on this example. And if I scroll a little bit down, and then there is the model layer, and it allows us to package these things together. But what we don't have in this example is you can also package arbitrary parameters to a model as well. So if you have your own parameters, different parameters that you want to package, you can put them all into kit file. And this is actually saved as a layer in your OCI image, OCI artifact on the model kit. So later on during the life cycle of your project, you can retrieve them and use them. But its main role is basically just to define what each layer is about. And then the CLI and the PyKitops. The CLI is what you would expect. It's very similar to what you can think about with Docker CLI or Podman for that matter. It allows you to create pack model kits, manage them, deploy them using kit files. Um, what else? We have a feature for importing them from Hugging Face if you prefer it that way. We also have a dev mode which you can run them locally if you want to do a quick testing and so on and so forth. And on top of that, we have PyKetops, which allows the Python applications to have access to the Kit CLI. And here's a list of commands, and this list is a little bit outdated. We actually have a import command now. So, but as you can see, this pretty much provides you everything that you would expect to use model kits in essentially a pipeline. So what does the project look like? We have 5 full-time maintainers that are Josu employees. We do have 1, 2, 3 regular outside contributors to the project. And overall, I think we're at 20 something. At the time of these slides, it was 21. And some 600-700 stars on GitHub. I can't really remember. We do have over 30,000 downloads in the last quarters, 2 quarters. The project is Apache 2 licensed. Most of our governance is code of context and similar is essentially taken from CNCF already, although we haven't become an official CNCF project yet. We do have users, especially in government and technology and manufacturing, which we are not yet able to disclose names, but we're working on that. So, yeah, we have actually gotten very early interest on this from the areas where compliancy is a concern. So what does our roadmap look like? Right now we are almost finished with the metadata improvements on our tar files. And the Hugging Face import is we're testing that out. The next thing for us is MLflow integration and documentation. So we do have a lot of users on MLflow who started to come up with their own ways of integrating GitOps with their MLflow runs. So we're trying to come up with a more streamlined way of doing it at the moment. So we're working on that. And also our goal is to follow up the changes through for the CNCF specification on GitOps. So when talking about the CNCF specification, so let's talk a little bit about the standardization. We do actively participate on the specification that is happening around this. We intend to keep GitOps as a reference implementation of the specification. And the presentation is already linked to the document, and if you want more information, we have a project website, a GitHub, and a separate GitHub for the PyKetops, and we are active on Discord.
Awesome. Thank you for sharing. Any questions from folks here to Gorkum? Okay, I have one then. So PyKit is the SDK to interface with the project, or what is PyKit in that case?
So PyKitops is essentially a wrapper around the Kit CLI. So most cases, except for the model, the Kit file generation, it actually uses the Kit CLI underneath to package a model kits, unpack them, pack them, run them, all that kind of information, all that kind of um, uh, work is done through PyKitops. Uh, a if your pipelines are written on Python, usually you kind of use PyKitops instead of um, individually invoking the CLI. So we have users in both sides of things. So we do have GitHub Actions. We do have Dagger modules that you can use for using Kit CLI, and then you have a big chunk of users who actually have their uh, either data pipelines or the training pipelines in Python that would like to have access to Kit CLI.
Awesome. Right. Thank you for sharing. And OCI is always exciting. So I'm 100% for it.
What question?
I mean,
so
yeah, go ahead.
the project is already in Sandbox and the CNCF, and
It is candidate right now, so I think
Okay.
we're good. It's going to be reviewed this month or next month. Yeah.
Got it. Okay, great. And right now, most of the maintainers are part of Josu, right? And are there any external users right now, like
So
organizations?
there hasn't been anyone that we have designated as maintainers yet. We do have a few regular contributors to the project, but official maintainers, we haven't designated anyone yet.
Got it. All right. Looking forward to seeing the project grow.
Yeah, I mean,
100%.
I guess that's the idea, right? Once we always intended GitOps to end up in a foundation, possibly CNCF. So once we moved into a more open governance, I'm expecting more contributors to come in.
We have a question from Claudia. It's on the Slack. It says, "Are there any demos for this?"
Yeah,
I can.
sorry, I can elaborate more. Yeah, then I thought maybe I can just go and take a look at the Git repository. That's what I'm doing now. So I see there's a bunch of links. So I was more on the, of course, as you can imagine, Kubernetes side. Like, how would I do from 0 to done if there's some guidelines where I can?
Yeah, I mean,
I'm very excited to try it.
Yeah, we have a demo that shows I can post that as well. That may be interesting with OpenShift.
Yeah.
Yeah.
Instruct Club being mentioned somewhere in the Git too.
Yeah, we did work with the Quay team at the Instruct lab for a demo actually.
Oh, that's great.
Yeah. There's actually one. Oh yeah, I think this is the one. Yeah.
Okay, awesome.
Yeah, cool stuff. I'll share the link also for folks here.
Oh yeah, thank you.
And our the GitOps being an OCI artifact has interesting properties as well in means of security and compliance. We do have actually one of our customers do that. They actually create attestations and attach them to OCI, and now trying to come up with a way to implement policies on them. Unfortunately, the policy engines of today do not always work with this kind of stuff yet. So they're coming up with their own ways of doing it.
Maybe, yeah. So Anka was kind of, I think that may be interesting for you, Anka, and Vikas, I guess. Yeah. But yeah, the SBOM thing was OCI. I think it makes things always smoother because you have an artifact that you can sign and trust and all of these things versus like everything is ad hoc along the,
and it's immutable, right? I mean, that's the like that's the most interesting bit on that. It's immutable, so you will be able to verify that much easier.
Absolutely. Awesome. Any other questions about GitOps?
Yeah, I have one question. So I'm new to this whole field, so maybe this is naive, but like can you use GitOps to probably package a model into container image? Like, is that
So
potentially-
yeah, okay. So GitOps itself is not a container image. It's an OCI artifact. But an OCI artifact is made out of layers. So because it's made out of layers, you can very easily take a layer and put that into a base container image. So, whoever is looking into that, if you look at the deploy tab here, so this is our hub implementation. And what this one does is it actually has these base containers like the Docker, the basic and Llama CPP container, for instance. What it does is it takes a base container and takes the model layers of the model kit and merges that into the 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 Docker container essentially. So because it's all layers and it's essentially tar files, that way we can create a Docker image for any model on the fly without rebuilding it. So this is exactly an implementation of that is just built into our hub. And this way you can just like creating the Docker image is not even part of a pipeline anymore with this.
I see. Okay. And did you face any limitations with like big models and creating like OC artifacts out of it, and then probably dealing with the registries since they are not?
Yeah, you get into that like not it's some of the registries actually have those sort of issues. We actually had to do certain things in our CLIs, CLI to be able to chunk things into more manageable pieces for registries. Unfortunately, OCI is a specification, but not everyone implements the specification the same way. Like there are certain ways of uploading and downloading that is specified in the specification. Even Docker doesn't do. So we run into those sort of things, and certain registries have limitations on the size of the OCI artifact that you can push. But usually those are very easily configurable. So, I mean, so far we haven't really had anyone complaining about that with the current sizes.
Right. Okay.
Yeah.
Yeah, because I can see this particular like whoever is sharing like it's 75 gigs. So it certainly takes some time to bring it up. Yeah.
Yeah, I mean, our SaaS uses our own OCI registry, so it's our own implementation essentially. So this one has obvious less limits on sizes, but we use Hub with other OCI registries as well, and we rarely run into any real problem with those. Usually the size limits are very configurable.
Yeah, and I saw a 7TB model there, so I guess like their
Yeah.
sizes, it's not a concern. I'm not sure about 100 billion or more, but yeah, most of the use cases these days are 7TB is quite capable.
Yeah. And also there is the work that is ongoing with the cryo and containerd for mounting the OCI images, right? So that may also be a way of running models by just letting the container runtime mount that into the pod. We're still a little bit not sure about whether that's going to be any better performance when it comes to delivering the models, large models into Kubernetes, but we are actually now working on doing some performance tests on different alternates to see if what's the best way to go, or in what situations actually is the best way to go. But OCI is very cacheable as well, so that there's that.
Absolutely. All right. Yeah, I guess like so we're halfway through and we have another presenter. So just asking one last time, any last questions about GitOps before we move to Erica? Going once, twice. Right, twice. Erica, floor is yours.
Awesome, thank you. I'll try to be fairly brief, but because you can always find out more elsewhere. Can I share my screen? Is that all right?
Absolutely.
Okay, thank you. I'll be very brave here and share my entire desktop as we kind of move around a little bit. And I'm going to click share. And I hope you are not seeing yourselves, but you are seeing my screen.
We're seeing your screen loud and clear.
Awesome. Great. Hi, my name is Erica Huberg. If you don't know me, I am part of the Envoy AI Gateway project that is part of the Envoy project. This is a sub-project, so I'm going to explain that a little bit more and what it is about and why do we care? Why did we even do this? How did it come about? And just want to give you an introduction to Envoy AI Gateway today. And I want to also tell you about how people like yourselves who are part of this community can help support and enable us to ensure that Envoy AI Gateway is a really good solution that actually addresses real people's needs. Okay, so if you're not familiar with the Envoy project, but I do think a lot of people here are familiar with the CNCF landscape, one may even say that the Envoy project is one of the dinosaurs amongst the CNCF project. It's been around for a long time, but even dinosaurs do evolve as the industry gets more needs. But it's really cool though that Envoy does help us address some of the problems we started seeing. So hopefully I can, no, that's not what we're doing. I'm trying to slide forward. Okay, great. As we probably all know, we saw a massive rise of Python-based gateways as the Gen AI era sort of exploded, and the amount of traffic we saw of Gen AI traffic. Why? Because, of course, a lot of the smart people who did awfully smart things with generative AI, they knew Python real well. So they were real good at writing really cool stuff in Python. So they started building gateways in Python. However, if you've been around for a bit and dealt with the challenges of networking and large numbers of concurrent connections, because that's where things started to get more, and this amount of traffic of Gen AI started being even more. The amount of concurrent connections we need to deal with just exploded. however, there were some benefits with Python. We were able to do some smart semantic analysis of the requests that were coming in, because Python, again, has lent itself very well to dealing with natural language and semantic analysis, and really helps us leverage these new Gen AI features. Okay, so that's kind of sad, right? Python fundamentally, with its global interpreter lock, is actually a really bad gateway, being an interpreted language, but it's got some cool features to help us do cool stuff and analyze incoming requests. I mean, I think we all care a little bit about things such as semantic caching. Sounds exciting. I don't know if people here care about such things, but I happen to do, who like making sure that things are connected, reliable, and stable, and also, you know, fast so we can make it and save some money. So we were starting to run into a problem, right? And this is how I met Dan Sun, which you may know, working at Bloomberg, and he met him in the Envoy community because he approached us in specifically the Envoy gateway part of the Envoy community, and was like, oh, maybe we can do something here to create something robust in open source, built together, built in the open. Because if you do look around, there are definitely other solutions for AI gateway type capabilities that are built on Envoy proxy. And I do think that those people who made those decisions made very sensible decisions and arcs. And it's very much to do with the handling of concurrent connections. Happy to go into the details and nerd out on that with anyone who's happy to. But we'll move on a little bit. I want to give those who may not know about Envoy and what on earth it is, the fastest crash course in the Envoy ecosystem. So first, about 8 years ago, there was something called Envoy Proxy, and it really came about in the era of microservices, and we were breaking down the monoliths, and we wanted to have lots of little services. And then we had to like dynamically configure and connections and handle large numbers of concurrent connections. So Envoy Proxy was born at Lyft and was donated to CNCF. So that was Envoy Proxy. Keep in mind, this is just a proxy. It's a reverse proxy. It's really good at directing traffic. But if you have a proxy that you want to configure without a control plane to actually configuring it, it gets a bit tricky. So many people built their own control planes to handle configuring Envoy proxy. But later in the Envoy project came about the Envoy gateway. Now you'd be like, wait, isn't gateway and proxy kind of the same thing? Well, what's Envoy gateway? My little illustration here hopes that you can figure that out. Now I'll explain what this is about. You see now all of these purple little things around there, the little hexagons, they are your proxies. And in the middle, you have a teal colored one. And let's think about that as the gateway. That is the master configuring and controlling all of these. And why did we call it Envoy Gateway? It was as the beginning of the Kubernetes Gateway API came about, and Envoy Gateway implements and extends the Kubernetes Gateway API to help you easily configure all of these proxies. But then as we all know what happened, we wanted to start making Gen AI traffic. We were handling that. So, well, now we were hitting some of the limitations and challenges of what we were dealing with, both from a data plane. That's what we call proxies, data planes, the things that handle the data flowing around. That's the data plane. So the purple little guy, he didn't necessarily have all the functionality he needed to deal with these new type of traffic. But the control plane to the left here also didn't have all the type of configuration APIs to make it easy to configure the proxy. So we have to then extend that a little bit. So the Envoy AI Gateway project is not a fork, not something different from proxy or Envoy Gateway. It actually depends on both. So when you deploy Envoy AI Gateway, you're actually deploying Envoy Gateway as well, which in turn also deploys a fleet of Envoy proxies. So they all come together. They're not standing alone. They're a family, a family that depends very much on each other, especially the new little guy on AI Gateway can't exist without the other two. So that's my crash course on what this is about and what's going on. So Envoy AI Gateway leverages Envoy Gateway and Envoy Proxy to enable Gen AI traffic handling. And maybe you guys are the guys who are real informed here, but the first time I heard about the idea of an AI gateway, I was like, what's wrong with all our API gateways? What was wrong with those? Aren't they good enough? Like, what happened? That was my first reaction. To be fair, now like 8 months later, I did realize it pretty quickly at the beginning there when I started looking into it that there are some challenges here that are a bit different from our traditional API traffic. So when I first connected with Dan in the open source, and we started pulling together what is the initial deliverables and what we're doing here, we wanted something that was scalable. So if we're talking about those concurrent connections, because that were the issues we started running into with the Python gateways. We wanted it to be easy to extend, dynamically extensible. Envoy proxy, great job. So those two things, scalable and extensible, wonderful things that Envoy proxy was already really good at. So that's sort of like the freebies we get. Then the next thing that we wanted to ensure was implementing a unified API. So as a user or that wants to integrate with different Gen AI, especially at this point, was that is LLM unified API focused to make sure it's easy to integrate and you don't have to worry about who the provider is, so that you can change that independently of having to update all the apps, and also making it easier for developers to just simply integrate. Usage control is another one. So this is obviously when we start running into those initial problems where our traditional API gateways were falling a bit short. We have been counting number of requests for however long, right? Ever since the era of beginning with API gateways, we had measured how, like, requests per minute, requests per hour, quotas. We only counted requests. So what we really want to get in is usage control, that in the LLM world, based on those tokens, like the word tokens we're talking about. And then we want it to be fault tolerance, and that also fits in with the unified API notion, and that is allowing a user of Envoy AI Gateway to configure a backup fallback in case the LLM provider they may be using is down. So in sad situations where OpenAI goes down, you can fall back either to another provider, or maybe you want to fall back to a self-hosted solution. So our initial features that we've been focusing on is very much this high level, what we refer to as a Gen AI gateway that is able to route to providers. And then you come into the next phase of this, beyond solving this problem, is to go closer to Kubernetes and also implementing the inference API extension to the Kubernetes Gateway API. But as we're looking at this 0.1 release that is imminent, we should be landing next week. We're just going through the final, dotting the I's and crossing the T's to make sure it's all pretty and nice. But that's where we're at. And I want to tell you how you can get involved. You can come to our community meetings. You can meet us on Envoy Slack in Envoy AI Gateway channel. You can find us on GitHub. And we want you to bring expertise, questions, and ideas. This is like my little pitch and my crash course, but I'm sure everyone, and I don't know, I'm going to show you the most boring and quickest demo ever. So I've deployed Envoy AI Gateway locally on my machine. I'm using Docker, Kubernetes engine, and this is the most boring thing where I'm going to show you how I'm interacting with this model. I'll send a request. Oh my God, we can't answer. How fun. They're going to say something else. And then sending to, so we're interacting with GPT-4o here. We're getting a response, hopefully. And we can also send them in terminal. So all fun and games. That's the most boring demo ever because it's in a terminal and a bit of Postman. But from a deployment point of view, this was from nothing. I just connected to my Docker desktop cluster and moved on with deploying. And I think it takes about, well, just a few minutes to have it up and running in your Kubernetes cluster. I have also run it with Ollama before and connecting to locally hosted models, but for this demo, I just connected here. If you are interested in the deep dive of the architecture, happy to answer any questions of how things work. Otherwise, you can check out the link. I think I added the link in the meeting notes and you can read in detail. I can talk for forever, so I better stop talking now in case someone wants to actually ask a question. I don't want to go into rabbit holes and details for those who may not be interested, but my biggest ask of anyone in this call who may have ideas for features, context, expertise they want to bring to this project, would love to hear from you, would love you to come and share your perspectives with us. Because I think there's a lot of people on this call who know a lot more than I do and can help bring their knowledge. Okay, I'll stop talking now.
This was great. Thank you, Erica. So questions? I have mine, but I'm sure all of you have.
Some hands up.
Yeah, I don't know who wants to go first, but
There's Deep and Andrew. I don't know who you
Go ahead.
first.
I think you were first.
Okay. Yeah. Thank you, Erica. I think that was helpful. But I have a very basic question. Whether this gateway, AI gateway or whatever you call it, is it really aware about the workload, or it just the other way? Because you use the term inference API. So
yeah.
either this API is smart and able to use the gateway in a smart way, or gateway actually understand the payload or some other attributes and as actually able to scale or whatever functionalities you were explaining. So what is the, I mean, is it really aware about the AI, the gateway itself?
So the gateway itself is the first version, 0.1, is only concerned about routing to I need to get another diagram. I don't remember what that is, but I'll try to explain. So when we are looking at this first version, we're looking at it, think of it as a tier 1 gateway. It doesn't know if you are this routing to self-hosted model, it knows nothing about how your self-hosted model is hosted. Okay, it has actually really nice integrations with providers. So something we've done is to have a upstream authorization functionality in the gateway, so you don't have to rotate credentials to, for example, AWS Bedrock. It auto rotates those. You set it up and it can then auto rotate to short-lived credentials, which actually takes a massive burden off the users who go from their client app or script or wherever they got to the gateway. They only have to authorize to the gateway, and you can have your own internal authorization mechanisms. That's what we see that users do. Often companies and organizations have their own authorization methods. So they will authorize that, but also Envoy Gateway provides really nice JOT-based authorization. So you can do some really nice logic there. And then the gateway, like the proxy, is doing upstream authorization to the providers. So the gateway, from the provider perspective, it is the gateway that interacts with those services from an identity, the identity of the system that is calling. And that's really helpful, especially in large organizations. Then the next version, 0.2 of Envoy AI Gateway, there is a extension to the Kubernetes Gateway API that is going to allow us to do more intelligent routing to self-hosted models and that will take into consideration things as GPU usage and also making sure routing is as efficient as possible and it will use something that's called inference pools. And now we get into some more details of how Envoy will handle that. But that is coming next. That was not from our interaction with the users, wasn't the first and most important thing that they cared about. They cared about this unified API, having abstraction and usage control of external LLM services.
Awesome. Thank you. One more question, just quick. Can I also run this in a sidecar, or it's something else?
This is a gateway. So when you deploy it on a Kubernetes cluster, Kubernetes knows it as a Kubernetes gateway.
The resource, right? So it's like a Kubernetes resource, right?
Yes, so it's all configured through Kubernetes resource. So if you look at this API reference, they are resource kinds and there are supporting types. So it's all, you leverage you leverage the basic gateway API resources like gateway. Then there are extensions in Envoy Gateway that has its custom resources that extends the gateway API. And then we further extend the API with Envoy AI Gateway with new resources like AI Gateway Route, for example. That's some new items here to look at that are introduced. So hopefully that, yeah, exactly. It's
I
all
think
Kubernetes
I
resources.
got it. Yeah.
Thank you.
Yeah.
You can run this in a standalone mode eventually, because Envoy Gateway has a standalone mode, but no, would not run it as a sidecar to something.
Yeah.
You could in the future run this inside a Docker container without having it plug in with your Kubernetes per se, so you could just run it as a service without it being a Kubernetes gateway. Hopefully that helps make sense as well, but not right now. But that will be possible thanks to the work that's being done on the Envoy gateway side.
Got it. Thank you.
Andre, you had a question?
Yeah. Thanks, Erica, for this great presentation. I just have a few questions to you. So you mentioned about the challenges compared to, like AI inference endpoints and just in a normal application that we all know about, right? Can you tell more about
Normal APIs.
about LLMs, like, what challenges you're facing with?
So when we had to looking at the traffic, so when I say the challenges we had from a traffic point of view is when you have you go back in time, you have a normal, not back in time, we still have them, a normal API, maybe you just have a simple API that's like user or pets. We all know about the pet store API. Like you are distributing these APIs either internally or externally, right? Imagine you are distributing them even just internally in your own organization. How we used to put in rate limits and quotas, they would have been based on the number of requests. Whereas when we deal with these APIs, like the LLM-based, like completion APIs, the chat APIs, right? We have this challenge that it's the same API spec, but the cost of computing and responding is very, very different. So you can have simple things, and that can come back with something very small, and it can go really quick, or it can be really long running and complex. And with our traditional microservices, or even wherever they were running APIs, they were more deterministic. So we knew that if we send a request, we should expect the backend service to take 5 milliseconds to put the response together, roughly. And we know if it's more than 20 milliseconds, we should probably start sounding some alarms inside of our own observability systems because something is not right. The service is unhealthy, even if it's responding. Our world of Gen AI doesn't function the same, right? So other meshes and observability starts becoming interesting. We are actually more interested in like the speed of response tokens. So if you're thinking of you streaming the response tokens, you're actually more interested in how quickly those tokens, if you are streaming back, versus how long it took to respond with the whole thing. So both on the observability side and on the usage control side, you see differences in how you need to tackle those challenges.
Yeah, I think that makes sense. And did you make any kind of like, do you make any guardrails around like, context windows or like how those, the endpoints can be called, like in terms of, like control the hardware and like, the cost around the request to the LLM?
So right now, the initial focus is based on calling external service providers like AWS Bedrock or OpenAI or Azure OpenAI. So in those scenarios, the key thing we focus on was capturing input tokens, output token usage. And that was a big thing about unifying this API so that we can get that information into a standardized format. And then we enhanced Envoy proxy itself to be able to do rate limiting. We're now calling it cost and usage limiting, so that we can measure number of tokens used by whatever bucket you want to define. You can do it based on app and end user. You can do it based on app or whatever other attributes you may have. So you have to create your bucket. We are not, in this iteration, worried about self-hosted compute usage of models.
Yeah, that makes sense. Makes sense.
As we are moving to implement the gateway API extension for the inference, now we're starting to be interested in more things because now we're self-hosting the models, right? So now we are running into even more interesting challenges. But,
but I guess like basically right now you're kind of like operating still like in a black box, right? Because you don't know like what would be like, the response time for the backend service, right? When you're calling the OpenAI API, right? Or any
you
other.
don't know how long it's going to be, and that's all right, but you want to monitor the performance. And if something is not behaving, you may want to fall back to another option. So fall back. So you know if it's unavailable and you know how quickly it's responding. We do know that. We know how quickly it's streaming its response. So we know how many, the token response rate per minute, for example. We can know that. Does that make sense? How it operates inside it's not what we're observing. We're observing how it impacts us.
Yeah,
And
maybe
we
just
are,
go
yeah.
ahead.
Yeah, no, I'm trying to just make sure I understand what you want to observe, because often the users we've spoken to are very concerned about the number of tokens they're actually consuming from these external providers, and that token usage is what they want to control. So that is what we are able to control in this initial release.
So also, I think some of these services are also charging by number of tokens, right? So that's also
That is why we are measuring the number of tokens and controlling token.
Yeah, I remember like
consumption.
previously in the KSRF meeting we were discussing to making tokens are like first class citizen in terms of calling those APIs, right? So it could be based not on the request but like on the tokens, like how many tokens actually like LLM responds to you, right? And based on this you can measure the performance or other metrics, because it will be different compared to like like a normal API application, if I understand it correctly, like how much cost you need to, right?
So there's a couple of different things there. One is measuring how reliable and fast it's responding. You want to measure rate of tokens in response streaming per time unit, minute, second, whatever you like. And if you want to then enforce usage on the applications calling your gateway, which is proxying traffic, you want to control their usage by something in LLM world that would be tokens. So you're controlling usage not per the number of requests they made, but per the tokens they have consumed, and you are capturing the amount of response tokens that was given back to them.
Yeah, I think this is great because you can also monitor, but I mean you can control, but you can also monitor, and then you can also measure SLOs, so organizations want to, provide like a guarantee for internal teams or external teams or whatever they're servicing, right? So, and if you have the metrics, it's great. So.
Yeah, it's like really one of the I guess if you're familiar with Envoy proxy, I think really one of its, hero features is definitely its ability to surface observability metrics. Definitely like something it's really good at. So it's like, again, how can we lean into these things in a good way? And those of you who know Huamin, I guess a lot of you know Huamin here, something that Huamin has demoed in the Envoy AI Gateway community meeting, which I think is really cool, is how he's added effectively custom external process filters that are using Python. And what's really cool about that is that we can bring the smartness of Python capabilities without interfering with the connection handling. So the problem we have with Python gateways is that they struggle to handle large numbers of concurrent connections due to the global interpreter lock. But if we are using an external process that's independently scalable and not handling connections from clients to gateway, or from gateway up to the services, we're able to utilize smart Python stuff without interfering with connection handling on the gateway side. So it's getting a bit of the best of two worlds. So I think it's really cool what Huamin's done with those Python extensions. That anyone could write their own thing and plug into this gateway for their own personal needs.
Okay, Gorkan, you had a question on the Slack, so I want to make sure.
Oh, sorry, I'm not checking your Slack, so I don't know.
Sorry, not Slack, the chat. Sorry, the side chat.
Oh.
Yeah, I can just ask it. It was more of a like a roadmap question, right? The inference extension to the gateway API. Do you have like a timeline on when the Envoy gateway is going to implement that?
We want to have it implemented before April. There's already people working on the design of how we implement how we do the control plane here. So it's in progress, if you put it that way. People are looking at it, people are looking at the design of it. So then it's just a question of people's time to be able to contribute and implement it. But I'm quite excited about where that's going. I think worth noting there is, as far as I'm aware, on this Envoy AI Gateway open source project, there is no single person out there that is 100% like full-time sponsored by their company to work on this. So either people are like myself, I get to spend some of my workday focused on this. It's not 100% of my job. And yeah, I don't know of anyone at the moment who gets to spend. So
Yeah, but
that's
like,
I just want to
there's
highlight.
some,
We well,
that's
group of
how
merry
open
men and
source.
women.
Yeah, that's how open source works, right? But okay, so it's on the way, but pending whoever picks it up.
There's some people that picked it up, but then it's how quickly does that move?
Yeah,
You
well,
know.
that's fine. That's
Yeah.
fine. It's even the API itself is pretty new, so
Yeah, it was only like last week it was like properly in alpha.
Yeah.
So it's
Do we know?
we've decided to pick, so for my community meeting yesterday, actually, we decided to pick that up and really make sure that it happens. Yeah.
Is the effort from working observing happening completely async from Envoy community? Like the gateway they also proposing the gateway API.
This is the API is just the API, right? So it's a question of implementing API because an API is just a dream if there's no implementation of it. So
I see.
different solutions are implementing the API. And the idea, I believe, is that Kubernetes gateways all over will be implementing this API. So if you are like using a different Kubernetes gateway solution, I hope that that one also implements that API. The reason we want to make sure that in the Envoy ecosystem, there is a control plane that implements the API is that the control planes in the Envoy ecosystem are the only control planes that release together with Envoy proxy. That are part of the same community. We follow the same release cadences. We are like, the community is like tied together from data plane and control plane in the same open source project. What you will see, there are commercial solutions, other open source solutions that also leverage Envoy proxy. So like you will see, I know that even there are other control planes for Envoy proxy that implement this, that are either working on implementing the API. So, and I think then it's just a preference of the user, like what they want to use. But yeah, it's all everything will need a control plane to implement the API. Otherwise it doesn't do anything. Yeah.
Cool. I know we're out of time.
Oh, sorry, I talked too much again. I'm
No,
so
it's
sorry.
awesome. It's awesome. Thank you for sharing. I like maybe before we go, do you have anything or any links to you want to share other than or something demos maybe you want to put
I put some link in there.
Okay.
So you have a link to the that architecture piece, and if you navigate around on that site,
Okay.
you will find there's a community tab. There's like join us
Yeah.
on Slack, the weekly meetings, the GitHub discussions. There's a getting started guide. Feel free to try it out. Let me know if you get stuck while trying it out. We want to make sure that people can actually follow it. There's a lot of work coming up with people wanting to creating transformers for more and more providers. I know GCP is something a few people are focusing on next. Azure OpenAI, of course. But if you are someone who want to help work on more transformations or just help bring prioritization to things, like, as I said, I think there's lots of people here who can bring their knowledge and experience to help bring prioritization and focus to some features based on your expertise and experience. So I really appreciate you. If anyone, you don't have to come and contribute code. If you contribute opinion, I am also very grateful.
Well, thank you all for your
When,
time. Ricardo, go ahead.
Yeah, so one follow-up, but so if you have any links to share, like you mentioned, also this is for Gorka. Feel free to share them on our Slack channel, like you said, like community links or anything. So we have a number of people on the Slack channel, so hopefully we can get more folks in, right, in all those different things.
And Mona, you have your hands up.
Yeah, actually, I
thoughts?
had an item, but there is no time at all. I'll just I want to share. Like, I know that the time is over, but just give me a couple of minutes, because I saw in the backlog that you are trying to define the landscape and the reference architecture for the cloud native workload, for the AI cloud native workloads. And I think I already asked a question right there, because I was trying to figure out the focus areas of this working group and where the focus is, because I found that there is another working group working for data and AI stuff. So I tried to have a map, a very just one second. Like, I just try to have a map to lay out the architecture, or not the architecture. It's just like the overall, like how we can categorize and structure as the machine learning workloads in the cloud native ecosystem. So I come from VMware, and whenever we try to lay out a reference architecture, we try to understand the structure of the whole thing first, and then we try to lay out a reference architecture. But the thing is, with ML, what I found to be really challenging is that the ML lifecycle contains different stages, and those stages can be categorized using other categorization mechanisms as well, like the compute and the scheduling requirements and the execution model. I want to go into details. We can talk later in the other meeting, of course, but I'm just trying to have like a 10,000 foot view of how can we have a view of the workloads that run on in the cloud native space. So each stage, in my understanding, have its own requirements on compute and infrastructure. And if we can, because you are trying to have to define the landscape as well. So I know that the Kubeflow is the one that brings ML ops to Kubernetes, but still, like, there are other things as well, like storing the data and the data stores and everything that can be deployed on top of Kubernetes. And I think Andre is here. Andre is like the Kubeflow, one of the Kubeflow leaders as well. But it's not only, as I said, it's not only Kubeflow. There are other components that are included as well in the ecosystem. So I was trying to have this map, and I think I'm not sure how far are you in this regard, defining the landscape and the reference architecture, and if we can lay out all the solutions that are in the cloud native space for each stage, and what are the gaps and what are the challenges, because I saw different initiatives, but I'm trying to get the big picture first, and then we go into the challenges that face every stage, if that makes any sense, and if there are any gaps that needs to be addressed. Okay,
So,
I'm done.
Yeah, just quick pointers. We do have a landscape. Have a look at that. If you see something missing, please, you know you have, this is awesome. So feel free to contribute to that. There's also a scheduling cloud native AI white paper effort. I will put the link in the chat.
Yeah, I have it.
Yes,
yeah.
so have a look at that. We were looking for people to contribute and continue the effort. So you can take the artifacts you produce here. I think they are very relevant to scheduling, and maybe potentially like update the paper, and maybe other folks will join and get excited. But I would say these are two quick pointers. We can continue the discussion next time. Thank you for sharing this. This is awesome. Feel free to put a Slack link to that. And yeah,
Absolutely. I will be happy to.
Yeah, Mona, so if you can share also this link on Slack. I mean, I don't know if this is a Miro board, and maybe
This is my Miro board. Yes, I will share it. Yes.
And folks can collaborate maybe if they're interested.
Yeah, absolutely. Yes. Yeah.
Awesome. Thank you.
Awesome. Thank you, everyone. It was an amazing meeting. Looking forward to seeing you again. All right.
Thank
See
you.
you.
Bye.
Bye.